Today on the Perception in Action podcast, how should biomechanics be applied in sport to improve performance and reduce injury? Should we be identifying ideal movement parameters from group-based analyses? Or attempting to optimize for each individual athlete? And a discussion with Mike Sonne and Casey Mullholland about the development and use of ProPlay AI, a phone-based app for biomechanics analyses. So it's time for a call to action. Hi everyone, this is Rob Gray from Arizona State University and PerceptionAction.com. Welcome to the Perception in Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. In today's episode, I want to look at how we can use biomechanics to enhance the performance and reduce the injury risk of athletes. A great article that gives an overview of different approaches for applying biomechanics to sports was published in 2019 by Paul Glazier and Sina Medizadeh. As the authors discuss, two basic approaches have been used in applied sports biomechanics studies: contrast and correlation. Contrast refers to studies in which the mean values or standard deviations for some movement parameter, for example a joint angle or a rotation rate, are contrasted for two different groups, for example different ages or different skill levels. An example of this is the 2009 study by Flamin and colleagues, which compared the standard deviation of different movement parameters including elbow flexion, lead foot landing position, and shoulder external rotation for pitchers at different skill levels. It was found that there was a systematic decrease in standard deviation for most variables as you move from youth to high school to college to Major League Baseball. The typical inference drawn from this type of result is that performance will be improved if less skilled performers are trained to have parameters more like the expert. For example, in this case, more consistent pitching delivery. More on that in a second. The second approach involves measuring the correlation between different movement parameters and one or more performance parameters within one group of performers. For example, a group of professional golfers. An example of this is the Glanzer and colleagues study I talked about back in episode 156. In this study, they explored the relationship between various parameters and a performance variable for pitching, the variability of pitch location. As I discussed in that episode, they found that 5 kinematic parameters were significantly related to the consistency in locating the pitch. Again, the assumption here is that if we could train people to adopt these movement characteristics that correlated with performance in the study, their own performance would improve. As Paul and Sina nicely discuss, a problem with using these group-based approaches is that they mask the likely functional variability between athletes. This error is sometimes referred to as the ecological fallacy. Quote, propositions about people cannot necessarily be derived from propositions about the mean of people, because the patterns found by aggregating data across people do not necessarily apply to individuals. A classic example of this is making economic decisions based on the average income in a society with a large upper and lower class. There are actually very few individuals that are at the mean. As I discussed back in episode 156, yes, the kinematic parameters in the pitching study could predict 58% of the variance in the performance variable, but what about the other 42%? From self-organization theories of motor learning, we know that there's likely a lot of important differences between individuals lying within that 42%. For example, differences in kinematics due to differences in individual constraints, such as height. Trying to coach everyone up to the mean ignores this important individual variability. It is very likely that training all performers to adopt the average quote-unquote ideal movement parameters identified in the studies will be counterproductive, unachievable, or even injury-producing for some athletes due to differences in the individual constraints and incompatible intrinsic dynamics. Furthermore, as evidenced by the coordination profile studies I discussed in my interview with Wolfgang Schulhorn in episode 304, if we looked at elite athletes, we'd likely find that many don't exhibit all or even some of these movement parameters we found in the study. The alternative to these one-size-fits-all approaches is, of course, to take an individualized approach in attempting to identify an optimal movement pattern that is best for each athlete. As discussed in this paper, there are again two basic approaches here. The first is to do the same type of correlational studies relating kinematic variables and performance, but within a single individual. So, for example, I could bring a pitcher into the lab and have them throw fastballs over and over, then look at how their kinematic variables related to a performance variable. So I could ask questions like, which elbow angle results in the pitch that was closest to the target? As the authors discussed, there are a few shortcomings with this approach too. First, if we keep the test conditions the same, which we'd most likely do when we brought someone into the lab, it is likely that there will be very little variation in the movement parameters, unless we're studying a complete novice. The inherent variability we see in skilled performers tends to be quite low. That is why standard deviations of kinematic variables tend to be smaller at higher skill levels, as we saw in the Fleissig study of pitching I mentioned earlier. Where we see variability in skilled athletes is when the conditions change, as happens in the real sporting environment. In other words, it's not just variability, it's adaptability we are seeing. And as I like to say when teaching stats, you can't have covariation without variation. If movement patterns are not changing very much from trial to trial because the constraints are staying roughly the same, you aren't going to be able to detect how movement parameters relate to performance. The second issue is that old performance versus learning issue. The whole purpose of doing an individualized biomechanical optimization is to improve the performance. In other words, we don't want to know what aspects of their movement results in the best performance with their current technique. We want to know what changes to the current technique might result in even better performance. If we correlate movement and performance parameters in a non-elite athlete, it's very likely we're just measuring a local optimum in performance. That is the best solution within the set of possible solutions the athlete has tried or been coached. What we really want to find is the global optimum. That is the best solution among all possible solutions for the individual. We don't want to just describe what they're doing now, we want to know what they're capable of. The alternative method for individualized optimization of a movement solution is through some sort of modeling in which the physical parameters of the individual, for example their height, arm length, etc., are used as inputs to a model which attempts to predict the optimal technique. For more on this, please check out episode 159. But the bottom line here is that contrary to the claims you might hear, the approaches used in applied sports biomechanics cannot currently reliably identify the aspects of an athlete's technique that are associated with better performance, or even with reduced injury in most cases. Nor can they reliably predict what changes should be made to technique. Consequently, we need to do a lot more work to be able to effectively apply biomechanics analyses to sports. In what follows, you will hear my interview with two people trying to do exactly this, Mike Sonne from ProPlayI and Casey Mullholland from Kinetic Pro. Mike and Casey are working together to address some of the issues I've been discussing, and, as you will hear, are taking a very measured and systematic approach to this problem. They are also addressing another important issue in this area, accessibility. Most biomechanical analyses take place in a lab using very expensive equipment and often sterile, non-variable conditions. ProPlayI is an app Mike is developing for doing biomechanical analyses anywhere using your phone. Listen at the end to hear how you can be involved in the beta testing for this product if you're interested. I hope you enjoy our discussion. Hi, everyone. Welcome to another edition of the Perception and Action Journal Club. It's my pleasure today to be joined by Mike and Casey, who are going to tell us about this new product they're developing and using called ProPlayAI. Right, it's a tool for doing biomechanics assessment and analysis with a particular focus on baseball. Right now, baseball pitching, I think, but maybe you talk about some other things. So before we get rolling on that, I thought I'd let you guys introduce yourselves. So I'll go down, Casey, I'll let you go first for introduction.
Sounds good. My name is Casey Mullholland. My background is actually from the playing side of things. Jumped into the coaching side of the game in 2016. Got released by the Los Angeles Dodgers at the time due to rotator cuff surgery. My background was supposed to actually be a first-round draft pick out of high school. I missed it by about 6 days of Tommy John surgery, and that sent me on this catalyst of trying to figure out, what can I do to stay healthy, and led me to a bunch of great places, met a bunch of great people, and when I got done with my playing career, quickly realized my network and decided that I could do some work to help guys not go through what I went through. So we are here now with Kinetic Pro.
Cool. And Mike?
Yeah, so I'm Mike Sonne. I'm the VP of Innovations and Research with ProPlayAI. My background's actually in ergonomics and occupational biomechanics. Did my PhD at McMaster University up here in Hamilton, Ontario, Canada, and found my way into baseball probably about 5 years ago, kind of when I started applying some of the ergo stuff around muscle fatigue and muscle fatigue accumulation into the pitch clock world. So thanks for having me on, Rob.
Yes, I know your fatigue units are your FUs. I've read a few things about those. So, well, one of the best names. But yeah,
that was the fun part of not having to get it peer reviewed. You can come up with whatever name you want.
So maybe we'll start. You can start. Maybe tell us about. So this is a phone-based product for doing biomechanics, and maybe kind of the emphasis. I'm not totally up on the biomechanics, but I think like most people, I kind of know there's two extremes. There's the labs where you have a emotion tracking system that costs a fortune and takes forever to put trackers on. And then the other end, you have people using still images and trying to draw little angles on things. So, which has its own. So what was the impetus for this and how did you get started?
So I'll dive a little bit into the ergo space to kind of give you some context on all of this. So when we started writing the papers on doing our fatigue units or looking at the effect of pitch clocks, it was applying an ergonomics-based model to the baseball space. And I started looking at it from the perspective of ergonomics. In ergonomics, when we're talking about injury, we look at three things and the interaction of those three things. And it's force, it's posture, and it's repetition. And when we were looking at baseball pitching, the force side is pretty straightforward. It's somewhat related to effort and velocity. Mm-hmm. The repetition side is trying to better understand workload, which we know is a lot more than just pitch counts or innings pitched. And that's kind of where fatigue units came from. But then the final one was the mechanics side of things and understanding a pitcher's mechanics or their postures as they threw and how that related to injury. And a few years ago, we had a master's student at Brock University study with Dr. Mike Holmes and I named Richard Burfer. And Richard, his master's thesis was to basically try and apply some of the same methods we've used in ergonomics, where we look at a still frame at a still position in time. So right at foot strike, we're just looking at image at foot strike and trying to see how accurate people were in assessing that compared to motion capture. And we had a bunch of scouts and coaches do that evaluation. Mm-hmm. And that was going to kind of be, okay, we can maybe use this. And it turned out, they were right maybe 50% of the time, not even 50% of the time. Mm-hmm. Now, around that same time, we started using some of this markerless motion capture to start measuring job demands and postural demands in the workplace, primarily assembly line type work. And I remember one day just kind of, I think hanging out probably before softball or something, filmed a friend throwing and said, hey, this might work from this. And we kind of just took off from there and said, what can we get? How accurate can we be from cell phone video compared to a motion capture lab? And, our initial results are we're about 3/4 to 85% as accurate as a motion capture lab. And there's some metrics that perform better than others, but we're getting a lot better than we had when somebody's just using a still image or kind of using their subjective approach.
Okay. Yeah. And I know I think you've talked about some of the limitations of using those other approaches. I know one of the big ones people talk about it for people, there's the parallax issue, right? With a still photo. If you're side on and versus an angle, the same joint angle is going to be different, right? Yeah. Depending on, so you without knowing that, so there's some big issues. That sounds really, really interesting. And Casey, where did you come into this? You mentioned you had an injury as yourself and sought to try to understand it better. How did you kind of connect with Mike and your approach to this?
Yeah, so Ben Hansen actually with Modus Global connected us. And so I saw Mike online on Twitter and again, just the network, right? Baseball's a tight-knit community. And I was always seeking new answers. I actually stumbled upon Mike's FUs, which became obviously very popular. So he and I reached out actually before the winter meetings this past year. And And we just got in touch over Twitter, started talking. At the winter meetings, we kind of hit it off and discussed what workload management was, how we were using it in facilities. So one of the big things that we've done over the last year and a half is really took the Modus Global product and built out throwing progressions based around our overall workload for guys in the off season. So especially with our professional athletes, we were able to develop systems based around one day workload values, and then calculate out for them what they should do in season or how they should be prepared for season. It took a lot of Mike's work and actually, built a lot of our programming based around that. So Mike kind of hit it off. My guy kind of hit it off in that space, talking about workload management and how to grow it within the game. So,
to be clear, it was workload management and bourbon. Those are the two things that caused that relationship to really flourish.
That'll help it. Yeah. So the modus you're talking about, are you talking about the modus sleeve? And
Yes.
what is that? That measures for? What does that measure?
It measures valgus torque. So on the elbow, it's So every throw, we're calculating valgus torque on the elbow, and we're able to actually develop. So what I did was I built a program based around one day workloads with that. So we can plan whether you're doing plyo care throws or long toss throws. Each and every throw that a guy performs, whether it be in facility with us or outside of it, we're able to track that and then basically plan out what's ahead off of what they've done in the past to avoid fatigue.
Okay, so I'm gonna keep simplifying this for me. So it's rotate. So that's like rotational force around your elbow joint, right? How much force you're putting on your poor little UCL as a pitcher. So are you looking for Are you looking for kind of the amount of time they're above a certain range, or just kind of like are you kind of adding up the total force, or how you kind of? Yeah.
So one day workloads take into account volume and intensity. So when we are looking at an athlete, we want to be able to say, okay, early in the off season, we want a lot more volume. We don't want a lot of intensity. So we can plan for that through our one day workloads. As our fitness level increases, our chronic workload increases, then we can start to increase intensity like at a specific rate. I use about 10% to 15% with our guys through the course of the off season. And then we deliver them in season at a specific fitness level that meets their requirements, whether they are a reliever or a starter. We help guys understand where they need to be.
Okay. And Mike, so with is the biomechanics connection trying to identify the body positions, how they relate to force and
Yeah, absolutely. I think at its core, that's, we're trying to understand what motion characteristics are related to elevated force levels on the elbow or, on the shoulder. But it goes beyond, just understanding it from an injury perspective as well. Like there are characteristics of movement and timing of different segments of the body moving through space that are related to throwing harder, throwing more strikes, being in more command. So I think that's really where, we're trying to present Pitch AI and the pro play as a company is to understand injury, but also to understand the things that go into performance.
Yeah, no, I think that's a great point. When I try to, a lot of times something that's going to cause injury is also likely breaking the kinetic chain, which is going to affect velocity or something along the line, right? So they work hand in hand. Yeah, I think that's a great point. And so your initial kind of approach with this, are you're collecting data from a lot of different pitchers at different levels and kind of establishing a database? Is that kind of where you're starting with this?
Absolutely. Yeah. So, before everything kind of went crazy, we were in Phoenix. We won't talk about the golf game Casey and I had when we were in Phoenix. That never actually happened. But the goal there was to understand two things. One, how do high level throwers move? And to do that, it was really just a matter of capturing a bunch of in-game and bullpen data whenever we could. And the second thing was, kind of related to a blog post I wrote a little while ago, was to understand how we could break Pitch AI, to understand when its limitations would really start to kick in and to come up with best practice for capturing video. Because as much as, we're saying it's 75 to 85% as accurate as a motion capture lab, that comes with caveats. We do require open side video and there is some flexibility in there, but it was really to understand, what are best practices for capturing that type of video so that we can use it for biomechanical analysis.
Yeah. I watched your video on that and it's really impressive. I like you said, there's best practices, but it's pretty. You can kind of just walk into an open practice, even when there's multiple. You mentioned there's issues with multiple people around, but it still can work depending on So there's a best way to do it, but still you don't need this perfect sterile lab. You can do it in the game. You can do it on the mound and on the field at night. Even it was a bit tricky, but
that was more on the operator. I needed to adjust that ISO setting a little bit better, but once I got that, we were looking pretty good.
Yeah. And so, Casey, what have you been using it with so far?
So our athletes, we typically have somewhere in the ballpark of 20 to 50 athletes that come to our facility on a day-to-day basis. So the issue with a motion capture lab, as we've talked about before, is number one, the price barrier is, for facilities like mine, where, I had a minor league salary. It wasn't great. I came out of it and just looking to do good and trying to help guys out. Our business has grown, but we're still not at a point where we could afford $300,000 biomechanics lab. So the ability for Pitch AI to step in as a open side camera that you already own that sits in your pocket on a day-to-day basis, that ability to capture guys through that, it helps the owner, number one, but number two, the rate of feedback for our athletes helps the athlete. And as the app starts to get moving, and it starts to function more fully in its ability to actually spit out pitch-to-pitch reports, our guys will be able to use that objective feedback to make adjustments and to determine, did I get here or did I not get here? Much like you see other technologies in the game today looking at pitch design or other functionalities, guys can utilize that and lean on that data to determine, was this a good breaking ball or not? Was this a good pitch in terms of mechanics or not? And I think that's where Mike and I really talked. We've done a little bit of a research project. We're starting to kind of weed through the data now, getting 20 athletes so far through our facility, collecting 5 pitches each. And we're starting to determine, okay, this is what we're starting to see through our guys. We have guys that, I think there's 3 guys on that data set that throw 100, and we've got a couple of guys that are 13 years old. So you have a wide range. We're starting to see a much, much broader picture of what mechanics truly are.
So are you trying to relate kind of the mechanics, joint angle, all the things you can measure to pitch outcomes? This tends to make for a higher velocity, that kind of thing. Yeah.
Exactly. We want to see what performance looks like. We know that there's a barrier to get to college. If a Division I coach comes to a game and watches an athlete, the first thing he's going to look at is he's going to pull his radar gun out and say, do you throw, 85 plus or not? And if you don't, then he's going to put the radar gun away and probably walk away.
Yeah.
So.
And that's interesting, the pitch. So I think people that don't know, the kind of pitch design you're referring to is, you get a pitcher to let's move your finger slightly this way, slightly there, and then see what it does. We can measure the break and everything on the ball now. So you're doing the same things in terms of biomechanics, try whatever, bending your arm more, striding longer, and you can actually collect that data and show them. And do you actually show them I think you have kind of stick figure feedback, right, Mike? Is that what you're using? Mm-hmm.
Stick figures. There's lots of graphs and just those charts. And Casey's had a lot of success with communicating. Here's your leg angle, and here's your shoulder, and here's how they interact in time, which was something that we're constantly trying to make it so that we can make biomechanics more accessible. It is very heavily driven by complex measures, and Casey's done a really good job of communicating with the athletes. And I think once you hit that kind of threshold with the athletes where they're understanding what you're saying and you can communicate it through numbers, it really opens up a whole nother playing field. And Casey's done a great job with that.
Yeah. It'd be interesting to hear how you're doing, because I know, I think there are a few years ago, I remember an ASMI study where they brought in a bunch of people and did biomechanical analyses and kind of made technical recommendations for changes. And then they measured to what extent people could implement these changes. And it was not very good. But I think the problem is the measurement and the person trying to do the correction is not connected, like in your case.
Yeah, absolutely.
Yeah. So do you want, go ahead.
So when I think that we have to look at the industry's change like this, it's we're getting all this objective data, and a lot of people are asking the questions of what do we do with it. And there's so many different tools. We have a 6-sensor program from Modus that measures range of motion. So we do an assessment with a guy and determine internal, external rotation of the shoulders and hips. And a kid looks at that and goes, it means nothing to me. What does that mean to me? But if I can connect his biomechanics report and say, hey, listen, we're seeing that your hip internal rotation is affecting your pelvis rotation, which is in effect affecting the kinetic chain, they get a basic understanding of that. They understand at the end of it that the more corrective work I do, or the more mobility work I do in this case, the better off I'm going to be. We can gamify the system for them at that point, create a leaderboard, say, hey, listen, this guy's really working hard. We can value certain types of training for that athlete. And within a facility setting, we can incentivize that athlete to say, listen, next time you test, we want to see these numbers go up, or we want to get into this range. Athletes do a really good job. They are very competitive. So they do a really good job. When you give them incentives, they'll go after it. We just have to hold it to a standard where it means something. We have to talk to them in their terms, and then get it to mean something to them to make affect change.
Yeah, I guess I maybe could direct this to you first, Mike, too. How much is this individual, right? I don't know if you've collected enough data. Is it variable, like the relationship between rotation and force, is not the same? Everyone has the same exact pitching motion, right? It has to be kind of individual.
Yeah, absolutely. And I think that's where I was taking a lot of exception to kind of how the industry was positioning a lot of biomechanics. And this isn't the entire industry, but very specific individuals who I felt were acting in bad faith by saying there's this one specific movement pattern that if you do this, you're going to hurt your elbow. When, from a pure biomechanics and anatomy standpoint, we know how much variability there is on like line of action from, origin and insertions, right? Mm-hmm. Like it's remarkable to understand how much variability is in the human body. From person to person. So to say there's one sort of mechanical set that is going to keep you from getting hurt, going to keep you from, throwing hard, it's absolutely crazy to think that. And I think one of the use cases that we've had for using Pitch AI is to validate what you are coaching. If you're using a cue constantly to try and get more external rotation or to work on lead leg blocking, film the person, introduce the cue, film them again, and see if it actually made a difference, right? Rely on the objective data that you can get out of this type of a process. And whether that's, ProPlay or Pitch AI, or it's a motion capture lab, or, you're working with some sort of a video analysis, you can't take a one size fits all approach to understanding mechanics. And, not to go too far off on a tangent, but Casey has a great story about one of his current athletes right now that if you were to look at this individual's mechanics, you'd say there's 3 big things that they're doing wrong. But then you look at the radar gun and it's 99. Right? So it's tough to say that there's a lot happening that's wrong.
Yeah. So what about you, Casey? What's with kind of the individual differences and things you're seeing?
Yeah, it's the same. I mean, I think one of the things I took exception to when I was younger was everybody kept telling me that if I don't change my mechanics, that I'm going to have Tommy John surgery. And I ended up having Tommy John surgery. But if you put, 20, 16-year-olds that were throwing 90 plus miles per hour in a room and you told them all they're going to have Tommy John surgery, you'd probably be more than half right. Especially back then when we didn't understand or really, quantify a single throw. We just looked at pitch counts, and we know that pitch counts in and of themselves are I don't want to say worthless, but they're not good. So I think from a pitch AI standpoint, from a biomechanics standpoint, we start to look at guys and a lot of the Twitter crowd. So you look online and you'll see a lot of information coming off of Twitter that's saying if you don't do these things, the same thing I was being told when I was younger, if you don't do these things, you're going to get hurt. And it's just not the case. You can, pull out, person after person after person that are elite level throwers. And, if we're evaluating their career, their future, based upon specific movements that they're either getting into or not getting into, I think we're missing the boat big time. So it's kind of really excited to see what Mike and the ProPlay stuff is coming out with. I think it's going to be somewhere that in the future we can shift the narrative a little bit and start to kind of poke some holes in this and look at, like you're saying, more individuality of each athlete as they walk through, find out what works and what doesn't work, and continue to build on it.
Yeah, no, those are great points. I know anyone that kind of follows baseball, every time there's a video of some young pitcher throwing hard, there's 10 posts about, he's going to blow out his elbow, right? Because he's doing the, but this certainly article I just did yesterday on one of these, we have this kind of egotistical assumption that we know more than your central nervous system does about how you should be moving, right? You kind of know something, figured out something. So, but I guess another thing I could say, connecting it, Casey, maybe Mike talked about, cueing, seeing if the person changes the movement. And then I think a lot of what people miss sometimes is then actually, does it matter for performance, right? To actually measure, maybe we get them to do the more leg blocking or whatever, but it doesn't change velocity at all, because a lot of it we think it will matter, but we still need to make that connection. So are you connecting the performance measures as well?
Yeah, absolutely.
Yeah. Cool. Yeah. Because I think that sometimes we have these assumptions, and so that's good. So the idea here is not to kind of identify key overall, things that everyone has to have to be injury to have effective prone. Is this approaching more individualized optimization kind of? Would you just
I would say yes. Yeah, I would say yes. And one of the features that we built into the commercial version of the app that's going to come out in July is just the ability to take those two stick figures and compare against yourself very, very quickly. And going back to some of the research that we've done here with Dr. Holmes and Ryan Bench and Richard Burfer, we put together a systematic review on kinematics as they pertain to fatigue during pitching. Mm-hmm. And I think that's really going to be where one of the most exciting utilizations of the tool is an understanding, how does somebody change throughout a game? How are your mechanics changing? Are you moving away from, that lead leg blocking, or are you, not optimizing your kinetic chain quite as much as you were when you were fresh? And, maybe that is theoretically putting more stress on the arm. We can start getting at those individualized changes, I think, as somebody performs. And I think that's really where the exciting stuff is, right? Is you're going to see some people who maybe their velocity goes down, but they keep their mechanics constant. And that person may not be at risk of injury. But from our review paper, what we found is that changes in kinematics typically happen before we see a change in their performance. And they are now transferring themselves into a different sort of movement pattern where they're putting more stress on their elbow or on their shoulder. Yeah. So that they can maintain performance. So if you're just looking at that one measure, chances are you're not getting the full story about how somebody's risk of injury is changing. And I think the same thing happens with somebody in Casey's facility there. Have somebody come in there and throw, and maybe one week they're hitting 95, the next week they're hitting 93, and they're reporting a lot of arm pain. Maybe that's because they've tried something different, or they're compensating because of another injury. All like kind of things that I think lead us to using this in an individualized sense to try and really better understand things.
Yeah, no, that's a really interesting question. I don't know if you have enough data to make an inference about this, but kind of, Casey, what's the kind of timeline between pain, performance, and actually kinematics? Like, so kinematics start to change, I think, way before pain. Pain's really a bad signal, yes. Isn't it? Happens way too late for most things. Like, think of putting your hand on a stove, right? It's way too late to prevent damage and things. But so have you kind of got experience? Can you pick up these kind of early signs before?
So the thing that I've been really interested in, the Motus League does a great job of providing one-day workload values, but it combines both volume and intensity. So one of the issues that we've seen is guys can be, the Motus League uses the AC ratio. And the AC ratio is a metric that we look at and give us a good general idea from a global standpoint, right? So if I took a whole team of athletes, I could use the AC ratio and its parameters to kind of govern, universalized programming for those guys. It gets very individual in terms of how we make those programs. But the one thing that it really lacks is the specificity of how quickly should we progress intensity. If a guy's throwing at 100%, do I throw 10 throws with him today at 100%, or do I throw 20 throws today with him at 100%? We really, we take a guess, and I've lowered our rates on that. But I think would be interesting to see, and this is something that down the road, again, just having this tool, being able to use this on a day-to-day basis. Watching guys as we introduce that intensity, that high intensity throwing off the mound, watch how their body reacts to that. If we're seeing substantial differences in terms of like slot, or if we're seeing substantial difference in terms of like rotation from even their catch play to the mound. We have the ability to capture those throws anywhere, anytime now. And that's a powerful space that nobody's really explored. So,
yeah, no, I think it's just, a more informed decision, right? Instead of the old 100 pitches, because it's a nice round number, right? Let's actually have some information to make a decision about when's enough. And yeah, that's really interesting. So you've been focused on pitching mostly, Mike. Is there a intent to look at other kind of hitting and then other sports as well?
Yeah, absolutely. Yeah. Right. And I think what makes the most sense is the approach we're taking, which is capture motion capture data, capture markerless motion capture data, come up with some corrective networks, that type of thing. I think that approach is scalable into other sports and other motions. Mm. One of the things I kind of learned while we were in Phoenix is that it will pick up a hitter's swing. Mm-hmm. The issue there was, we want to have some markered motion capture data to see how accurate it is. And, we were starting to do that. Things got shut down, but now we're, working with some partners to collect some of those data now, and we'll have hitting very shortly. And then really a matter of just, what other sports do you want to apply this to? We do have some of it already in the ergonomic space. Golfing is something that makes total sense. But then I think there's a lot of other types of motion and types of activities that you can apply this type of thing to, that it all makes a lot of sense. Yeah.
And for this product, are you doing so? So it's capture. You can capture the video on your phone. Sounds pretty simple. Really simple, actually. Yeah. I don't know anything about the options on my phone, and I could probably figure out. But then it gets sent to you're doing the analysis kind of offline. It's not kind of an automated.
Right now, that's the case. Yeah. So right now, the way that it's worked is Casey captures it just in the slow motion setting on his iPhone. Mm-hmm. He uploads those to a Google Drive, and then we analyze them and then return, CSV files and animations. But that's all being automated right now, and that'll work through APIs in the future. So, we're positioning this as a mobile app so that we can, get biomechanics into anyone's hands. But the reality is, through those APIs, it doesn't matter if it's cell phone video or if it's one of those, like the camera I was using in Phoenix, the Sony RX 100 Mark VI, or even something like an Edgertronic or something like that. Like, it really just matters that you've got the video and it's from a relatively open side angle, and we can return those data to you.
Oh, that's cool. A couple of questions I have there kind of related to my pet ideas, Casey, maybe, is have you got an idea from this about how the variability of delivery within the same pitcher, same pitch, like how important is repeatability versus are you seeing some changes from pitch to pitch on some of these measures?
Yeah, from my end of it, I can tell you this, from looking at ball flight data alone, right, before we even jumped into the biomechanics space and started to work with our guys more consistent with the biomechanics space, we see variability of pitch to pitch, almost every pitch. And then you start to see it from a biomechanics space, and you realize just how drastic the changes are pitch to pitch on most guys. Now, timing and sequence is not necessarily, I like to say drastic. If you graph it, it looks drastic, but we realize how small of a time frame that really is that the body is repeating itself. So I think it would surprise most coaches to know that the arm slot changes, a specific amount of degrees, athlete to athlete. Some guys are better, some guys are worse. I think it would surprise some coaches to know how much fatigue really plays factor into the changing of those mechanics. But I think that's something that, as this starts to come out, this becomes more accessible. People are really going to have to rethink, this whole discussion of, repeatability of changeup to fastball and slot, or repeatability of curveball to fastball and slot is much, much different than we thought it was. And, we have to take into effect the, rotational speed of the arm, take into effect that if the guy's throwing 99 miles an hour, really no matter where the curveball's coming out of at that point, it's substantially different pitch and very hard to hit. So I think we start to change at least our definitions of these things. What is repeatability? I think that's going to completely change in terms of how we approach the definition of it. But I think there is still repeatability, just it's how we quantify it.
Yeah. Mike, did you have some?
This has been like a pet project that I've been so excited about for some time because, I love the study of variability. And I recall very early on getting involved in some of the baseball discussions, and people were talking about, it's good to have variability in your release point. And I was kind of thinking, I don't know if that's necessarily true. There's going to be some variability, but I think a lot of variability in release point is going to be difficult to replicate. But now that we're getting kind of this full signal data on the kinematics, we can start looking at that variability that occurs before release point. And I think that's where it gets very, very exciting, both from a fatigue perspective, because if you're able to adapt kind of slightly minuscule different movement patterns, but still produce the same end result with a consistent release point, you're technically almost giving some different muscle groups different activity levels at times, right? And I think if we, I'm not a motor control guy, but if we kind of look at so don't start quizzing me out too much on, but if we start looking at things like the uncontrolled manifold hypothesis, right? There's variability that happens, and there's good and there's bad. And I think we can start to understand the good and the bad types of variability that happen during pitching when we can get a lot of data on how somebody's moving and how they move from one pitch to the next. And one of the things that we were super excited about at Brock University was that we were able to get a grant for the Canada Summer Games. Whether or not they happen still to be determined, but we can capture all the video in game during these games, and we can start to get to the root of some of these things, and do kind of full biomechanics assessments for every pitch thrown in that game. That that's exciting to think about.
Yeah, no, that's really interesting. If you're a variability lover, we need to have a beer or bourbon or whatever. That's one of my favorite subjects too. I've been doing the same kind of angle and hitting and kind of seeing the same things. The phrase we use sometimes in motor learning is repetition without repetition. So we're creating the same release point, similar outcome, but not exactly the same way. Right? You're moving differently to get there. And but I really I've speculated about this a few times. The injury angle of so we talk about doing things differently each throw is necessary because of just the way the body is, but the idea that might actually be beneficial in terms of reducing injury, I think is a really neat idea that no one's really explored. I don't know.
And I know to some extent here, like Stephen Oster, Dr. Stephen Oster, he works for Cleveland now, and he was the former performance director for Baseball Development Group, and he was big into understanding variability, and he still is. He's just doing it behind the iron curtain of professional baseball now. But understanding variability from that perspective, right? This comes back to what we know about variability within the ergonomic space. Those individuals who have more task variability reduce their muscle fatigue, and sometimes they reduce their injury rates, right? But the ability to use different muscle groups, the ability to recruit different muscle groups, and to change your arm action and to vary the amount of torque that's placed on certain parts of the body, I think that's absolutely instrumental to keeping people healthy. And I think it is one of the things that we miss from all of our current analyses because we haven't been able to really capture it.
And the other one I was talking about, kind of related, I call it kind of functional variability, is how the different parts of the delivery work together, right? So I don't know if you'd be able to capture that in your. So if I'm slightly early on whatever early part of a pitching delivery, how can I compensate for it later on by changing my shoulder rotation? Or Casey, do you have any can you assess that or your ideas on that?
I think a lot of it comes down to, in the baseball space, we talk about drills all the time, right? Everybody communicates and says we want to use constraint drills or, plyometric throws. I think a lot more, and something that's not said enough, is that it really comes down to what happens in the weight room. It's probably more effective to what actually occurs on the mound. When we talk about mobility and stability, I'm not going to be able to develop that having a kid throw a 8 ounce or 5 ounce plyo ball into a wall most days. We talk about rotation and the importance of the different segments, understanding and controlling different segments. We try to put it into our strength coach's hands and allow him to do his job and teaching the foundation there and then building it up onto the mound. So when we start to talk about the different segments and how they work together and the timing, it's completely individual and unique to everybody. And that's something Mike and I have really talked about is how do we quantify this? How do we say what is right versus what is wrong? I'm not sure I have an answer on that yet, but I do know, the general principles that we've walked through and seen in the past and what we've studied. But, we're going to work toward those because we think some of them might be right, but we're going to test the whole way through and continue to try to make determinations as to what is best practice here. And the more and more we get deeper into it, the more and more I'm finding my role as a pitching coach is much less in that space. It's more in the educational space and teaching pitching, not necessarily teaching moving.
Yeah.
So.
Yeah, and so I guess so. How with that is how do you find there's a big individual difference in how much players want information and how they want it? But this is something I've been kind of thinking about for a long time. We have all this data now. I've seen some teams that do ridiculous. They just give players a huge printout with everything on it. I couldn't understand it. But so do you find some players just want a really simple cue versus seeing the whole biomechanics output?
I have a theory on the gold standard of this.
Okay.
And walk with me for a second.
Okay.
So we've looked at different technologies that have come out now over the past couple of years, and we'll use Fitbit as the example, right? So Fitbit came out, and I'll use my mother for an example. She got a Fitbit for Christmas, and it became a family thing as who could get the most steps in the day. And she was always proud. She'd come home and tell me, I got more steps. I got 10,000 steps. I'd be like, oh, it was 9,000 today. And I'd be upset and want to go do more the next day because it was an environment, right? When we can begin to gamify this, we can begin to build a community around which players are more competitive. They self-educate because they want to find the curve that's going to put them to the higher pedestal quicker. So when we start to look at, the Fitbit example, if I gave a Fitbit to our guys in here and said, hey, Fitbit's going to measure your let's use daily strain as a discussion, right? You're in daily strain for the day, and we're going to try to also measure your recovery. Then, our guys in here are going to work to find new ways to get more sleep, eat better. They're going to try to recover better, and they're going to try to push harder. If they can see each other's scores, they basically argue with each other all the time. It's just bickering constantly, but it's good bickering, right? So I think the same thing applies to this space, and that's something we're really working on trying to put together, creating scoring systems to deliver really good content. There are some guys that they want the deep content, they want the deep discussion. But then there's other guys that are just athletes and they love competing. And if you give them something to compete for, they'll fight for it. So you have to kind of have two realms, both with kind of an end goal or the end prize in mind. Yeah.
Yeah. And I agree. And I've heard a phrase recently people say relative to the what's going on now, the pandemic, that when a measure becomes a target, it's no longer a good measure. But I don't think, and that's true if you want to just capture what's going on without influencing it, but you want to influence it, right? You want learning and adaptation, right? So I don't think that statement applies to this situation. But back to my other question, Mike. So do you envision a time when you can plot joints against each other? Sometimes we call it state space in motor learning. Yeah,
absolutely. Yeah, absolutely. Part of that comes down to education, right? And one of Casey's athletes that is actually working very closely with pro play is Nate Pearson, who's a prospect with the Toronto Blue Jays, and really hard thrower. But part of this is it's very exciting. It's very exciting to create a biomechanics lab that's in your pocket. All of that is exciting. But if you come up with data that's not actionable and it's not interpretable by the athlete, it's really quite useless. And Nate's big for helping us with that, right? If I'll come up with an idea, bounce it off him, and if it totally goes whoosh, that's not really something that we can go with, or we need to put some clarity around it. And Casey has been really helpful with that as well, because we show these metrics, we show horizontal abduction, and it's does this matter? Is this something that you actually need? And, how do we create an efficiency score? How do we create a balance score? How do we create a timing score? All these things. It really comes back to what, the goal you're trying to create with your throwing motion. And, Casey has an interesting story of an athlete recently who's coming back from an injury, and he's like, I really want to get my biomechanics assessed. I really want to. And Casey's like, no, you're not seeing that data because it's just not the time for it in that process, right? Mm-hmm. So, it's important to get the input of the person who's consuming the metric in the metric design, I think. But you're totally right in that sense, right? Like one of the hesitancies that we've had in creating like an overall, this is how good your mechanics are score, mm-hmm. is that I think it's something that, as somebody ages, their mechanics might change, and it doesn't mean that they're getting worse. It means they're adapting to their body and their body as it gets stronger or it becomes less flexible or, starts to feel the impact of years of doing a motion that is not inherently good on your body, mm-hmm. right? Like, what good mechanics are change over time. And, I think it's more about coming up with metrics around consistency, around balance, and getting into that space a little bit more.
Yeah, no, I think that's a great point. And not like that made me think of something in sports psychology. One of the things we obsess over sometimes is getting athletes focusing too much on their own body. Mm-hmm. We that's a theory about why people fail under pressure. We try to use external cues instead of internal. Casey, does this and you have any tendency to get people to do that when you give too much biomechanics feedback? Do you worry about that at all?
Absolutely. Yeah. And we try to structure our schedule accordingly. So I'll allot them days where I said, look, you can think, I'm okay with it. We want to get to a wall. We want to find different drills, different patterns. These guys want to explore what they're trying to accomplish. And one of the beauties of workload management is, you have a set value for the day. So getting to that value, depending on how how they choose to get there, really doesn't matter as much to me as long as they get to that value. So we'll have guys throwing short boxes or, short, pitching outings on a Rapsodo or other technology where they're spinning breaking balls and things like that. But when it comes to Tuesdays and Saturdays, which is when I label their competition days, I try to incentivize them again with, that gamification to say, hey, listen, you're pairing off against another guy. Our goal today is you're going to out throw him, whether it be velocity or command or, sequences through hitters. We're trying to create different types of training environments for them off the mound. So they have different visuals or different thought processes and they're competing with different goals. And then we basically extrapolate that over the span of the off season and drop them into season with as much as a game-like environment in the facility as possible. So they can jump into a game and feel like they haven't skipped a beat. They're just moving in and doing exactly what they've been executing for 4 or 5 months.
Yeah, no, that sounds really good. Good way to do it. I think you're right. Using it at certain times and focusing on different things. And I think. And do you think it gives better awareness? Do they have better awareness of their body position when they use this kind of technology?
Oftentimes, and this is why, going to how we structure off season, oftentimes when they come in, we can give them that biomechanics assessment early in the off season and say, hey, listen, when we're throwing low intensity, low volume, or you're moving volume up but maintaining low intensity, try to give them the ability to explore and try to create awareness early to certain movements. Because what we find is a lot of times when guys go 100%, they hit the mound and they're ready to actually compete. We had better pattern that over time and give them the ability to actually understand that move. They'll get frustrated if you try to do it bullpen to bullpen where they're competing, because when you put them in a competitive environment, if it doesn't come out with the desired result, they're going to go back to what they've done and they're going to abandon the process of trying to actually develop themselves to get better, so to speak. So if we're targeting a specific assessed metric that we're trying to improve, we set that goal early. We try to get them through that when the throwing is maybe less competitive, and then we try to build it into the competitive time frame so they can just more or less not think about it when they hit the mound and are ready to go.
Exactly what you were saying, Rob, right? You don't know better than your CNS.
yeah
Right. And one of the things Casey was saying there is that what you're doing in the weight room, what you're doing away from the mound is probably a better predictor of what you'll do on the mound than a cue about your mechanics, right? So I think that's, I think the misconception that everybody has about all this different technology in baseball is that they all live on an island of each other, right? Like a high spin rate fastball is the end all be all. Well, no, it is if you're working off of this other pitch or, it's delivered in this sequence. And I think the same thing goes for biomechanics, right? It's, your mechanics are good. However, if you've got perfect mechanics and, we're calling them quote unquote perfect mechanics, but you can't crack 80, chances are you're not playing at a Division I or a higher level, right? So all of these things kind of work together. And I think what we're seeing a lot in the industry now is just people are really hungry to try and tie everything together. And that's really where I think the biggest competitive advantage is to look at metrics from different devices, different technologies, different outcomes or different inputs, and be able to tie them together and connect those dots. And that's really where the exciting applications are moving forward.
Yeah, I really agree. There's no one magic pill, right? For this, it's just information, and I think the key difference I've seen is people using it like Casey's doing for development, right? So it's not just a screening tool where you're going to go, I'm going to draft this guy if he has this mechanic. You're using it as a tool for develop the athletes you already have, which is a really nice change over such a focus on talent ID and that kind of thing. Mike, you mentioned your fatigue units. So are you kind of putting this into I think I have a basic, I remember kind of like with like a relief pitcher, one of the big things in your fatigue units is how often they're used, how many days rest. So kind of most of like a time quantity base, but can you kind of start to tweak that by looking, actually models of how the mechanics change in that time period and things like that?
Yeah, and I think that's kind of where I want to go with this, and probably the thing that I'm the most excited about as we take this to market. And we work with Modus and we work with other companies to get some of this information, is almost the idea that you could say, if you want to get to a chronic workload level of this at this velocity, here's what the optimal mechanics look like for you, or based on your mechanics, here's the workload that you could be able to tolerate at this velocity level. And I think it starts to get kind of melded into that group there. We don't have anything right now on that front, but really like after, Richard's thesis and some of the work that we're doing now and the continued work that we're going to be doing with Pitch AI and our research team here with Casey and Kobe Close and our Brock guys, I think we can start to get to those answers, which is like super, super exciting to figure out the mechanical component of fatigue units, which, kind of closes the loop. There's our ergonomics based model on pitching. And, I always joke about anytime somebody's read fatigue units, I kind of trick them into reading my PhD thesis, which is considered punishment in some countries.
Yeah, mine would be definitely. So Casey, do you think this is like, obviously the way to go so obviously this arm injury problem in pitcher, there's a whole book about it. If you want to read Jeff Bassin's book, The Arm, about arm injuries in pitchers is an epidemic. I don't know if it's gotten any better recently, but do you think this is the way forward, kind of managing workload in an informative way, tweaking biomechanics and things like that? Is that kind of the way forward, do you think, for this?
Yeah, we hope so.
Yeah.
I think there's more and more evidence coming out on what we believe right now through the different technologies that we've been able to, have great groups build out over the last 5, 10 years. The technology is giving us an insight now to be able to see more consistently, with less time. It's shortening the feedback loop for the athlete. And there's every bullpen phone in our facility. I mean, we're collecting, I think, 12 to 15 data points on ball flight. We have a high-speed camera rolling. We're getting biomechanics feedback from OpenSide, from Pitch AI. And, we have a Modus sleeve that's collecting data every pitch or every throw. It's like, man, years and, 10 years ago, that would have been, a dream. It would have been crazy for people to think about. And the amount of time it would have taken to actually run that data would have been absurd. It wouldn't have done much good for the athlete. I think the big issue is we're running into an educational issue with, coaches and athletes, where you're getting so much right now from so many very smart people that understanding, trying to stay up to date on what's the latest metric to come out and understanding how to utilize it to develop your model. It's a night and day thing. I don't sleep much. I'm reading a lot, constantly trying to talk to my network and trying to see what's out there. But you want to do what's right for your athlete. You want to do what's best for them. And I think, building, there's gonna be a lot of other facilities like ours out there that are taking all of this in and trying to build their own models of their own development style. And, trying to just help athletes get better. It's really what it all comes down to, right? It's not about us or all the flashing lights when a guy throws. It looks cool, but at the end of the day, if it's not doing us any good, and we're not reevaluating our systems on a day-in-day out basis, then we're just not getting better. And the athletes are going to eventually see that and go somewhere else.
Yeah. So. Yeah. I think it's a really more realistic approach than, the idea we have to force kids not to throw. Like telling them if I want to be my dream is to be a baseball pitcher. Well, you can't play baseball in the summer. You can't play, you can't play all year round. You got to do another sport. You can't go to these showcases. Maybe that's better, but it's unrealistic. And then just to have hard caps of not throwing so much without any, basis for it. I think this is much more realistic way. You have to accept they want to do as much as they can, and they're going to, right? And so you have to do it in a safe way. Yeah. So I think that's a really a good approach. So Mike, kind of wrapping up here, Mike. So where does kind of this stand if people are interested in this and want to learn more and potentially use it when it's available?
Yeah. So our website is proplayai.com. I'll be regularly posting updates there on some of the research we're doing to develop the tool. Follow myself at Dr. Mike Sonne and follow Casey on Twitter. We'll be releasing all of the exciting research that we're putting together, and we're expecting the app should be available in July. So that's when we'll start rolling out invites to the product, get people capturing mechanics directly on their phones all across North America. Pretty exciting.
Yeah, that sounds great to me. Like more data, the better. Yeah, right. So,
of course.
Yeah. So, well, thanks very much, guys. I really appreciate this. A lot of fun.
Yeah, absolutely. Thanks a lot for having us, Rob.
Appreciate it, Rob.
Okay, that's it for today's episode. Remember, you can contact me at robgray@asu.edu or follow me on Twitter at ShakyWeights. To find out more about the podcast, please check out perceptionaction.com. Finally, to support the podcast and receive bonus materials, including written transcripts, please head over to patreon.com/perceptionaction. This is Rob Gray from ASU. Cheers for now, and keep 'em coupled.